Alright, complex power. Circuit theory, complex power. Laplace transform. Laplace is a powerful tool of the very weak electrical engineer transfers allow the equation of the time domain transferred into the equivalent equation of the complex S domain. Laplace transform of the integral transform allow the reader that does not have the acknowledged integral calculus because all the results will be provided. Page will discuss Laplace transform that being simple the tool to solve the manipulating order differential equation. Laplace transform is useful with a tool borrowed from the mathematics quickly, easily analyzed system representing a high order linear differential equation for Fourier transformer and closely transform closely related provided by the input and about with the frequency response characteristic system. Laplace transformation circuit element system similar to a phasor representation, though they're not the same. Laplace transformations are more general than phasor. They can easily be in some instances, but do not confuse them with complex S domains. The complex powers ideas we have been talking about earlier. Complex power usually variable S. The Laplace transforms usually variable S. Variable smaller s. Laplace variable smaller s has nothing to do with power transfer. By the name of the mathematician Pierre Simon Laplace, 1749 to 1827, transformed itself and did not make in particular Oliver Heaviside, famous electrical engineer, because of the variations solved with electrical circuits. Laplace domain with the complex S domain with the is the domain with the Laplace transform of the time domain equation as the complex variable that combines the real and imaginary. So we have the time domain equation is equal to Laplace domain's graph of the real part of the horizontal imaginary part width is the vertical axis, real parts imaginary, the time and complex variable consider the independent quantity similar with the notation of the Fourier transform in theory. No coincidence that the is equal to 0. Laplace is the same as the Fourier transform with a single cause. The transform of the mathematical definition of Laplace transformers. The transform of the virtue of the definite integral remove all the t with the resulting equation, leaving instead of the variable s. Complex number that normally is the s to the equal to I don't know what that is, but transforms it into a function and a general transform function as written for S time domain lowercase resultant S domain functions written uppercase. View the following notation to transform the function. The notation becomes to convert the fs back into the ft with the inverse Laplace transform form. Inverse transformer, Laplace transformer converts the function complex S domain counterpart with the time domain mathematical definition. The C is a real constant who starts with the poles of S1, S2 with the S number of the F function F with the falls on the region S amps less than the C the chosen, so the poles of the function S with the left of the vertical lines intersecting the real axis S and X. Inverse transform more difficulty mathematical transforms itself. Luckily, exclusive table Laplace transforms inverse computed available easier browsing. And Alright, Laplace circuit solution. One of the most important Laplace transforming solve with a linear differential equation, just like type of the equation with the representative of the first and second order circuit will discuss the Laplace transform to find the complete response of the circuit. So, if the general steps of the solving circuit using Laplace transform to determine the differential equation of the circuit, use Laplace transform of the differential equation, solve the unknown variable Laplace domain, use the inverse Laplace transform to find time in the domain solution. Another method will use the transform individual circuit with the impedance value of the Laplace transform with the transformer function. Describe circuit, solve an unknown variable Laplace domain, inverse Laplace transform to find with the time domain solution. This, of course, started with the phase that we learned with the transform forcing sensual function of the voltage into phasors to with the handling more complex forcing function, switches complex function frequencies, and enable handling forcing functions as a e to the st with a cosine of width. Wave with t at the phase plus phase angle s is equal to the convolution of and the convolution integral and do anything. Any along with S began with the transform the calculus operated back to algebraic complex domain. S could be reattached to the inductor's capacity with the forcing function of the transfer of that function helps the S to capture the circuit physical characteristics. This is given the design of a circuit operating with a single frequency width, but both circuits operating the variety of frequencies. The RC car may operate at 27 megahertz. controlling this process, the frequency might increase or decrease, or the amplitude may increase or decrease, the phase of the shift. All these things happen in a cell phone or with a Wi-Fi or Bluetooth, XP, with the AM, FM, over-air, TV, etc. How does a single circuit respond to these charges? For analysis, says we don't have the answer above the question, just one because of the answer. The design aim of the junction term of the series and sideshow added together, sweeping the circle with the various omegas that can be predicted with the particular combination. So start with getting rid of exponential terms, going back to phasors. Start with S is equal the 0 is equal to 0. Variable is known with the radio frequency, just frequency. Design circuit, cell phone, share air for set top cable, TV box back, multiple channels, black cable, each vocal pixel change during transmission reception design framework as required, sweeping the frequencies inside your voltage, current source, and produce. Analysis state of the frequency domain because they either repeats or over and over again, no matter going back in the time of the design point of view. Radio frequency, Fourier transform value width of the known radio frequency unit, radian seconds. My particular variable t, which called the frequency measure for the units, called the hertz of the conversion to the width of the 2 times pi to the frequency. For instance, the AC source of the frequency is 60 hertz, result in radio frequency width 2 times pi to the frequency, or 2 times pi to the 60 is equal to 120 pi. Fourier domain then broken into 2 distinct magnitude and a phase graph. The magnitude graph of the horizontal junction width with the horizontal axis, magnitude transformation vertical axis. Remember to complete the magnitude complexity of the C is equal A over the junction B. C is the absolute value is equal to the square root of A squared plus B squared. Phase graph of the junction wave horizontal axis favor the transformation vertical axis. Remember to compute the phase of the complex value, the C, and phase magnitude of the 4 transform arrow be independent values, although some of the abstract relationships do not apply. Fourier transform must include a phase and magnitude volt value. It can be uniquely transformed back in the time domain combination graphs of magnitude phase response circuit along with special types of formatting, interpretation, Bode plots. Bode plots transfer function transfer complex number of the multi-magnitude phase of the plotted in polar coordinates with frequent independent variable width of the swept of the range value with the major defined features such as the time constant resonant frequency magnitude with the decibel with the transfer function magnitude vertical axis phase plot typical degrees vertical axis, and then shows the MATLAB magnitude graph both magnitude of the decibel with a both measure of power and voltage current simultaneously vertical decibel axis with appropriate upper maximization relative to anything vertical axis of the axis with the number of the horizontal dependent axis of the radian second of hertz. Phase graph of the Bode phase plot with the graphs and radio frequency ready with the X phase shift of the circle with the frequencies on the Y axis radian degrees and frequency can be the radians per second or hertz. Poles and zeros transfer function. Some of the features of the realized circuit before looking at the features term pole zeros and origin needed to define started with the definition transferring function. Zeros are roots and enumerated poles and roots in the denominator origin of the S equals junction wave equal to 0 real part body and the frequency is 0 with an input DC after the long types conducting shorts. Some possible features: transfer function a constant 0 at origin of the numerator, poles of the origin of the denominator, real 0 at the S plus the A factor of the numerator, real part of the S plus the A of the denominator, complex conjugated poles, complex conjugated zeros. Your Bode and Bode plot function is available in the MATLAB system toolbox, and does the same thing discussed in Bode plot geo developed in some of the NSF, the similar with Hawthorne circuit simulation devices, circuitlab.com, Bode equation format, DC gain, break frequency approximations, radio at 0 radio frequency at breakpoint, conclusion impedance. Parallel circuit series solving circuits, 3-phase circuits.